Evening, dear student. In today's lecture, we are very much interested in the important point of our chapter magnetic material, that is hysteresis loop. So, what is this hysteresis loop? Hysteresis loop is nothing but a graphical representation between intensity of magnetization and intensity of magnetic field strength. So, what is this hysteresis loop? It is just a graphical representation of intensity of magnetization. It is denoted by symbol B. Sometimes it is denoted as capital M. And the intensity of magnetic field, it is denoted by symbol capital H. So this is the graphical representation between magnetization versus intensity of magnetization versus intensity of magnetic field. So if you see this diagram, or it is also known as Steresis loop, it having several points. That is, point A is there. It is known as saturation magnetization. It is the point A. It is considered as saturation magnetization, denoted by symbol BS. BS stands for saturation magnetization. Then there is a BR is also there. At point B, there is a BR. It is known as residual magnetization. Then the point C is there. It is known as a coercive field. It is a negative field. Then the point D is there. Again, D is your saturation point. So this is also your saturation point, but in opposite direction. Saturation point, it is in opposite direction. Again, there is a E is there, a retentivity. It is also known as whatever the residual magnetization in opposite direction, it is considered as the retentivity. That is, it is denoted by symbol capital E. And then there is a F point is there, that is coercive force is there. So what this graph indicate, let us discuss. So at least you should know the graph and the points, that is the terms involved in this graphical representation. That is, first, saturation magnetization. What is saturation magnetization? Residual magnetization, coercive field, and then retentivity. So let us discuss one by one. If we see with when the intensity of magnetic field is increases, so let us consider this point. This is your 0 point. So this is your 0 point. So here the intensity of magnetic field is increases. So what happen with intensity of magnetic field is increases from 0, then the intensity of magnetization or magnetism is also increases. So if you see this graphical representation, with increasing the value of H, the intensity of magnetization is also increases. The intensity of magnetization is also increases. That is, it is directly proportional. So the intensity of magnetization is also increases. The second point is that further increasing the value of H, again, if you increase the value of H, that is intensity of magnetic field strength, then the B value is also increased, and finally it is reaches to the saturation point. So with further increasing the applied magnetic field strength, the magnetization is increases and it is goes up to this point. That is your saturation magnetization. So it is denoted by point A in our figure. So further increasing the value of H, the B value is also increased, and finally it is reached to the saturation point A in our figure. That is, B is constant. So what it indicate, from this point, that is from this point, the magnetization does not increase. So from this point the B is constant. So here we can write the B is constant because the magnetization does not increase. So with increasing applied magnetic field strength, no doubt magnetization is increases linearly. With further increase in the magnetic field strength, there is no change in magnetization. So the magnetization reaches the saturated value, and therefore this magnetization is called as saturation magnetization. It is denoted by point A, where B is constant. With further increase in magnetic field, there is no increase in the magnetization. So up to this point, there is no increase in magnetization. So this is your point, saturation magnetization. So with further increase in magnetic field strength, the magnetization does not increases. So it is called saturation magnetization. The third important point is that if the field is reverse, that is, we can decrease the strength of applied magnetic field, or we can change the direction of applied magnetic field strength, then the magnetization or magnetic induction decreases slowly at first, and it reaches to the residual value at zero field. So we know that with increasing magnetic field strength, the magnetization is increases, and with further increase in applied magnetic field strength, it reaches to the saturation point. So in this hysteresis loop, if we uh, change the direction of applied magnetic field strength, that is, if the field is reverse, then the magnetization is also decreases. So if we see this, if we if we go from this positive value to the up to zero value, so this is your O or 0. Okay, this is the point. So H is go from positive to 0, then the magnetization is also decreases, and it reaches to the value B. It is known as residual magnetization. What it indicate? At zero field, the magnetization is not equal to 0. So this is the important point, that is, with decreasing the value of H, no doubt the magnetization is decreases, it will reaches to the point B. It is known as residual magnetization, but it is not 0. So what it indicate? When H is 0, when H is 0, when H is 0 but B is not equal to 0, B, or we can consider it is capital M, that is, magnetization is not equal to 0. So B is involved in these points, therefore sometimes it is considered as capital M. So what happened? With the decreasing applied magnetic field strength, the magnetization is decreases, and it reaches to the point B. It is known as residual magnetization. So what it indicate? When H is equal to 0, when the applied magnetic field strength is 0, the B is not equal to 0, that is, magnetization is not 0, and therefore it is known as residual magnetization. So this BR indicate the residual magnetization. The amount of residual magnetization left in the material after removal of field is known as residual magnetization. The material retains some amount of magnetism is known as retentivity, or residual magnetization, or residual inductions. So what is this residual magnetization, or it is also known as retentivity, or residual magnetization, or residual induction? That is, after removal of magnetic field, the material retains some amount of magnetism, then it is known as residual magnetization. So the first point is, it is a saturation magnetization. With increasing magnetic field strength, the magnetization is increases, but further increasing magnetic field strength, it reaches to the value denoted by point A. It is known as saturation magnetization. So with further increasing magnetic field strength, magnetization does not increase. So if you reverse the direction of applied magnetic field strength, Then the magnetization is also decreases, but uh, when the magnetic field strength is 0, then the magnetization is not equal to 0, because the material retains certain magnetization. Material left with certain magnetization, and it is known as residual magnetization. So it is known as retentivity or residual magnetization or residual induction. And the next important point is that further decreasing the value of H, so from 0 to negative. So we move from this 0 point to negative point. So this is the positive direction, this is the negative direction, this is the negative direction, this is your positive direction. So if you move from 0 to negative, that is further decreasing the value of H in the negative side, then the B value is also decreases at point C. So whatever the BR value, that is whatever the saturation, whatever the residual magnetization is left in the material, it is also decreases, that is it will also decreases at point C, and the material is fully demagnetized at point C. So this is the point. So the marker, it is not working properly, but you should remember. So when the applied magnetic field strength is 0, the magnetization is not equal to 0. So material left with certain magnetism, and therefore it is known as residual magnetization. With further decreasing the applied magnetic field strength, that is from 0 to negative, then whatever the residual magnetization left in the material, it is also decreases, it is also decreases, and it is decreases the point C, it is decreases, it is completely removed from the material at point C, and this at this point, that is at point C, the material is fully demagnetized, the material is fully demagnetized. So there is no magnetization in the material, no magnetization in the material, it is fully demagnetized. So this is the point, that is when you go from 0 to negative value of magnetic field strength, whatever the residual magnetization left in the material, it is also decreases, and it will becomes 0 at point C, and the material is fully demagnetized. The force required, so whatever the force is required to remove the residual magnetization, is known as coercive force, is known as coercive force. So this is the important point. So at point C, whatever the force which is required to remove the residual magnetization is called as coercive force, and the residual magnetization is lost at certain value of the reverse field is called as coercive field. So what is this coercive force and coercive field? So coercive force is the force, coercive force is the force required to remove the residual magnetization of the material is known as coercive force at point C, and whatever the residual magnetization is lost at a certain value of a reverse field strength is called coercive field. So whatever the coercive field strength is, what the value of field strength at which the residual magnetization is completely removed from the material. And what is this coercive force? So coercive force is nothing but the force which is required to remove the residual magnetization is called as coercive force. So this is the two important point, that is residual magnetization, then coercive field and coercive force. So whatever the force which is required to remove the residual magnetization is known as coercive force, and the value at which the residual magnetization is completely removed from the material is known as coercive field, that is at point C. Then the next point is the cycle is continue in opposite direction as shown in figure at point D. The cycle is continue. So same If we see the first one, that is with increasing the value of H in positive direction, the saturation magnetization is also the magnetization is also increases and reaches to the point, that is saturation, and reaches to the saturation magnetization value. Similarly, with negative value, with increasing the value of H in negative direction, it finally the magnetization is also increases, but it having a negative value and reaches finally to the saturation point, that is point D. So it is just opposite to that of positive saturation magnetization. It is a negative value saturation point, so it is a saturation point. E is retentivity. Again we go from this negative to the zero. Again we go from this negative value of S to 0, then the magnetization is decreases. So the magnetization decreases means what? The magnetization is go from negative to positive value, because in this case this is a negative part. So with decreasing the magnetic field strength, the magnetization is increases and it reaches to the E, where H is equal to 0 but magnetization is not equal to 0. So same case, that is whatever the B point is there, residual magnetization is there in above case. Same, the E point indicate the residual magnetization, means when H is equal to 0 but magnetization is not equal to 0, but it is in opposite direction, and if you see, the cycle is continuous opposite direction as shown in figure D is known as saturation point, E is known as retentivity, and F is called as coercive force in negative direction. The cycle is complete. So whatever this part, that is up to from point C, D, E and F, it is a negative direction, and whatever the point A, B, C and this F, that is whatever the line, the part above the line, it is your positive direction, and whatever the part below this line, it is your negative direction. So the cycle is completed and it make the hysteresis loop. So this is all about the hysteresis loop. This hysteresis loop, it is only shown by the ferromagnetic material. It does not shown by diamagnetic or paramagnetic material. So at least you should know what is hysteresis loop. It is a graphical representation of intensity of magnetization versus the intensity of magnetic field strength. So you should know saturation magnetization, what is saturation magnetization, what is residual magnetization, what is coercive force, coercive field. So these are the important parameter in this hysteresis loop. It is very simple. You just understand it and prepare your own notes for this hysteresis loop. So many times the question is asked in exam, explain the hysteresis loop with a diagram and explain the terms involved in it. In the next lecture we will discuss the remaining points of this chapter. Thank you.